Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be talking about how to write neutral formulas for ionic compounds. So let's get into this. What you need to do is to have an electrically neutral compound. So what does that mean? That means that the charges of your ions need to cancel out. So that does not mean that the ions no longer have charges. It's just that when you put the ions together, the charges that they still have are going to cancel each other out. They got to balance, right? So if you've got a certain total positive charge, then you've got to have the same amount of negative charge to balance them out so that they cancel. Now, they're not really canceling each other out so that the ions no longer have the charges. The ions still have charges in their compounds. It's just that they're balancing, right? So if you have a 4 positive for one ion, then you're going to need 4 negative for the other ion. And it's not always going to be 1-to-1. So a few examples that I have here. So here I have sodium and bromine. And so in sodium and bromine, sodium has a positive 1 charge and bromine has a negative 1 charge. So when you bring them together, they're going to cancel each other out and become neutral. And so you have negative 1 here. That's going to balance out the positive 1 there. So this is balanced out. So you'll see here it's a 1-to-1. You need 1 sodium to balance out 1 bromine because they have a positive 1, negative 1 charge there. Here you have calcium and fluoride ions. You'll see that the calcium has a +2 charge, but the fluoride ions have a negative 1 charge. So in order to balance the total 2 positive charge for the calcium, you're going to need 2 of the fluoride ions because each fluoride ion has a negative 1. So you're going to need 2 of these to create a total of a negative 2 charge. And that negative 2 will balance the 2 plus charge from the calcium. So the formula for this compound is going to be CaF2 because you need 2 fluoride ions to balance the charge. And so again, you have also aluminum and you have oxide. So aluminum oxide, the formula for aluminum oxide is going to be Al2O3. Why? Because in order to balance the charge, you'll notice you need 2 aluminums. Each aluminum has a 3+ charge. And so the overall positive charge is a +6. So you're going to need a -6 to balance that charge. And so the oxide ion has a -2 charge. And so you're going to need 3 oxide ions to get a -6 charge to balance the +6 of the 2 aluminum. So that's what you need to balance the charge. So the formula for this would be Al2O3. And so that kind of gives you an idea of what we mean by having an electrically neutral compound. And also to keep in mind, one of the things I want to point out is that formula should be lowest whole number possible. So we'll see here that I could have 2 sodium ions with a total of a 2+ charge, and therefore that I would need 2 bromide ions for a total of a 2 negative charge, and the 2+ and the 2 negative would balance each other out. So why not have the formula be Na2Br2? Or hey, why not why not Na3Br3 or any sort of combination like that? Well, the reason is because we write our formulas for ionic substances in the lowest whole number ratios as possible, and that's because ionic substances are crystals. You have hundreds of thousands of ions together, so the simplest formula would be the lowest whole number ratio for that crystal. So that's why we wouldn't write Na2Br2, we would just write NaBr for the formula. Okay, so what are the steps? Let me go over the steps and then we'll go over some different examples of how to go from the name to the formula. Okay, so First thing you want to do is, if you're given the name of your ionic compound, you have to know the names of the ions, and you need to know the names of the formula. So if you haven't memorized those, then you need to memorize those. So polyatomic ions as well. So whatever your teacher or your professor requires of you, you make sure you know those ions, right? So for example, so you need to be able to write the cation first and then the anion. So if I give you the name, like say sodium bromide, and I want you to write the formula for that ionic compound, you got to know what the formulas and the symbols and the charges are on their ions. So write the cation first, because the cation or the positive ion is always written first in the formula, and then the anion. So you're going to need to know what the charges are. So write the charges of each symbol and with the symbol. So you need to know the symbols and the charges of your ions, and that includes polyatomic ions as well. You should be able to also determine what the charge is of a monoatomic ion in the representative or main group elements, right? Those would be the elements in the 1A through 8A groups, right? So your S block and your P block, if that helps you call to memory what those elements are. So in group 1A, you should be able to determine, hey, that all of those are going to be a positive 1 charge. Group 2A is going to be positive 2 charge. Or let's say if you're 5A group, so if you're in group 5A, that's going to be a negative 3 charge, right? So you need to know those as well. And you should also know that the transition elements, right? The transition elements all have multiple charges, and so they're going to require Roman numerals, with the exception of 3 ones that you should know that are not going to have multiple charges, and therefore no Roman numeral. And those are silver, which always has a +1 charge, cadmium, and zinc, which also always have 2+ charges. So they're not going to have a Roman numeral. You just have to memorize those. And for the main group elements, tin and lead, although they're technically main group, those are going to have multiple charges. So those are going to need Roman numerals. So you got to know those. So that's step 2. Step 3, and this is where we talk about the crossing over method. So this is, we're going to use the crossing over method, and the crossing over method is where the superscript charges of the ions are going to crisscross. So what does that mean? That means that the superscript charge of one ion becomes this subscript of the other. So we're crossing over. So we're going to use the absolute value of the charges. You're not going to write the plus or the minus as subscripts. So basically you have your charges on top, right? And those are going to crisscross and become the subscripts. So the superscript charges, you're going to take the numbers, not the charge, just the numbers, the absolute values, and you're going to crisscross them and write them as subscripts for each of those ions. And then once you do that, make sure you reduce the subscripts to the lowest whole number ratio. So if it's 2 to 2, make it 1 to 1. If it's 4 to 6, make it 2 to 3, right? So reduce that to its whole number ratios. And then after that, you don't need to put 1. So if you have ones, then just leave it blank. Don't write a 1. So if it's NaBr, don't write Na1Br1. Just write NaBr. You don't need to write the ones. And also be careful of polyatomic ions. Polyatomic ions don't need a parentheses around them if you only have one. But if you've got more than one polyatomic ion, like NH4 plus or SO4 2 minus or anything like that, you know, your ammonium and your sulfate ion, you're going to need parentheses if you've got more than one of those, right? So make sure you do that. And I'm going to go over several examples of this right now, so I'll show you how it's done. Okay, so here are a few examples of how to go from the name of an ionic compound to the neutral formula. And so I'm going to go through all of these. So the first 8, I'm giving you the name, and we're going to work to the formula for the balance of charge of a neutral formula. And then the last three, we're going to show you how to go backwards. I'm going to show you how to go backwards from the formula to the name. And basically, you're just using the crisscross method in the opposite direction. So let's go over these examples. So barium fluoride. So again, first step is you write out the symbols and charges of the ions. The positive ion, the cation, is written first, and the anion is written second. So just like the name. So the name of the positive ion is first, the negative ion is written second. So barium is in group 2, so you should know it's a positive 2 charge. So we would write Ba2+. And then the fluoride, that is the fluorine element, atom of fluorine with a -1 charge. You should know that, okay, it's in group 7, so therefore it's going to have a -1 charge because, of course, it has 7 valence electrons and it wants one more electron, so it's going to gain another negative electron to have a -1 charge. So we have F-. So then the next step is to do the crisscross method, right? So remember, the numbers of the charges, the absolute value of the charges, are going to crisscross and become the subscript of the opposite element or ion. So here, the 2 here becomes a 2 subscript. So the 2 superscript here becomes a subscript 2 for the fluorine, and the -1, just the 1. We're going to take the 1 up here, the superscript 1, and write it as 1 here. But again, we don't write the 1s. And so then we have Ba1, we don't write the 1, and then F2. And that would be the formula. And then we double check to make sure this is the lowest whole number ratio. So 1 to 2 is as low as we can get for a whole number ratio. And so therefore, this would be the formula of barium fluoride. Okay, what about barium nitrate? So again, barium is the same ion, so that's going to be Ba2. So I'm going to write it over here. So we have Ba2+ charge. And nitrate, we need to recognize that as a polyatomic ion. So you need to know the polyatomic ion formula and its charge. So we're going to write that over here. So nitrate, you should know, is NO3 with a -1 charge. Okay, so now that we have our ions written with their symbols and charges, we use the crisscross method again. Remember, okay, so the superscript numbers become the subscript numbers of the opposite. So this 2 here is going to be a subscript for the nitrate, and this 1 here is going to be a subscript for the barium. And so we don't write the 1s. So again, this is going to be Ba. And so here's where we need to be careful with the polyatomic ion. So since we have more than one polyatomic ion, we're going to have to use our parentheses. And the 2 here, the 2 is going to be on the outside of the parentheses, but the ion formula is going to be within the parentheses. So we need to identify this as having 2 nitrates. So we're going to put the NO3 inside the parentheses, and then outside the parentheses is the 2. And so what that indicates is that we have 2 NO3- ions, so 2 polyatomic ions, 2 nitrate ions, to balance the charge of the barium. So this is our formula for barium nitrate. We can see that, again, the formulas, we're not looking at the 3 subscript here, only what's on the outside of the parentheses. So the 2 and the 1, that's the lowest whole number ratio we can get, 1 to 2. So this is our formula for barium nitrate. Okay, number 3, ammonium sulfate. So again, we need to know the names and formulas and the charges of our polyatomic ions. Ammonium is a positive polyatomic ion, so we need to write that down. So that's going to be NH4+, that's ammonium. And then sulfate, we need to know the sulfate ion. So that's going to be SO4 2 minus. And so here's the positive and negative ions. And so now we do our crisscross method. So we're going to take this number of the charge, the superscript, and we're going to write it as a subscript for the ammonium. And then we have this +1 charge here. So the 1 is going to be written as a subscript for the sulfate. Again, we don't write ones. So again, since we're going to have a 2 down here for the subscript, that means that we need 2 of our ammonium ions. So since ammonium is a polyatomic ion, we're going to put them in parentheses. So ammonium is going to be NH4. But since we need 2 of those, we're going to have parentheses with a 2 on the outside. So that indicates we have 2 ammonium ions. And then we have our sulfate. Now, since we only have 1 sulfate here, right? So the 1 here is a subscript here. We don't need parentheses, so we just write SO4. And so you'll notice that there's a 2 here. Don't make the mistake of canceling out the 2 and the 4. This 4 is part of the polyatomic ion, so we're not going to reduce that. If I reduce this to 1 and 2, right, that is no longer the sulfate ion. We've totally changed our substance, so we got to be careful of that. So we're not going to reduce this subscript here. So we only reduce the ions, we only reduce the subscripts that are on the outside of parentheses. If we have parentheses, then we're only looking at that which is on the outside of parentheses. If it's not in parentheses, if it's not outside the parentheses, but it's in the parentheses, we're not going to reduce that. So here we don't have any parentheses. So anything here is not going to be reduced. So this is the formula for ammonium sulfate. Okay. Iron 3 chloride. So here we have a Roman numeral. So we have iron. Iron is a transition element, and we have to remember that the transition elements can have multiple charges, with the exception of those 3 that I mentioned before: silver, cadmium, and zinc. Those are not going to have Roman numerals. You have to know the charges of those. Those are going to be, you need to memorize those. So remember, silver has a +1 charge. Cadmium and zinc have +2 charges on them. So here we have iron. Iron is going to have multiple charges depending on the substance. So it can have a +2 charge, it can have a +3 charge. The Roman numeral tells you the charge. So it doesn't tell you how many of the ion it has, it only tells you the charge. So remember that. So iron 3 tells you that you have a 3+ charge on your iron. So here we're going to write that here. So we have iron 3+. And chloride ion, so chlorine is in the group 7. It's a main group element. It should have only 1 charge. And so since it's in group 7, you need to know that it has a -1 charge. So Cl-. And so now we have our symbols, we have our charges. Now we're going to do the crisscross method. So this 3 here becomes a subscript 3 for the chlorine, and the 1 here becomes a subscript for the iron. So we're going to write Fe. We don't write the 1s. And then we write Cl with the 3 as a subscript. So Cl3. And here we can see that 1 to 3 is the lowest whole number ratio. We can't reduce it any more than that. So this is the formula for iron 3 chloride. Okay, next is aluminum sulfide. So aluminum is a main group element. It's in group 3, so we should know, hey, it's in group 3, therefore it has a +3 charge. Because why? Because it has 3 valence electrons. It's going to lose those 3 valence electrons in order to become stable, have an outer shell that's full, and so it'll have a +3 charge. So here we have Al3+, and sulfide, that is in group 6 along with oxygen. So sulfide group 6, we should name all the group 6 elements are going to have a -2 charge. So sulfide is S2 negative. Don't confuse sulfide with sulfate or sulfite, right? Sulfite is a polyatomic ion, SO3 2 minus. So sulfide, the IDE ending tells you, oh, this is a monoatomic ion. It's going to be sulfur with a charge. So now we have our ions with their charges. And so again, we're going to do the crisscross method. So the 3 becomes a subscript for the sulfur or the sulfide ion, and the 2 charge for the sulfide ion becomes the subscript for aluminum. And here we get Al2 and S3. And again, 2 to 3, that ratio cannot be simplified into whole numbers. So we keep the 2 and the 3. And so there's our formula for aluminum sulfide. Okay, next we have magnesium carbonate. So magnesium is in group 2. It's a main group element, so it's going to have 1 charge, and that charge is a +2 because it's in group 2. So we're going to write that here. So magnesium, Mg, 2+. Don't confuse this with manganese. Manganese is Mn. Magnesium is Mg with a 2+ charge. And so we have carbonate. Carbonate we need to recognize as a polyatomic ion. So carbonate is CO3 2 minus. And so here we got our symbols of our ions, our charges here. And so the next thing to do is our crisscross. So we're going to put a 2 subscript down here. So this 2 becomes a subscript for the carbonate, and this 2 becomes a subscript for the magnesium. And we're going to write Mg2, and then we have 2 carbonates, so we're going to have CO3, and then the 2 on the outside. So again, this indicates that we have 2 carbonate ions for every 2 magnesium ions. So now it has balanced charge, but now we have to double check to make sure that we can reduce or don't need to reduce the subscripts. And so here again, we're not looking at the 3 subscript on the inside. That belongs to the polyatomic ion. We're not going to do anything with that. It's the 2 on the outside, the subscript on the outside. So we're looking at the subscript here, and we're looking at the subscript here. So I know I talked about outside parentheses, but we never have parentheses for monoatomic ions, only for polyatomic ions. So the polyatomic ions are the ions that we are concerned about with regard to parentheses. So even though there's no parentheses here, this is a monoatomic ion, so we do want to reduce that if we can. So here we have a 2 and a 2 on the outside, so those are going to be reducible to 1 to 1. So we can reduce that to 1 to 1. So make sure that if you can reduce them and go ahead and reduce them. So there, and then we can get rid of the parentheses since we don't need them anymore, because you only need parentheses if you have more than 1 polyatomic ion. So here, CO3. So 1, 1 is our formula. So far so good. Next is zinc hydroxide. So zinc is one of those exceptions, right? So zinc is a transition element. Normally they have a Roman numeral for charge, but this one is one of the exceptions because it only has 1 charge, and that is at +2. So you need to know that. So, so zinc is going to have a 2+ charge for its ion, and the hydroxide is a polyatomic ion. And again, you need to know that as well. So that's going to be OH minus. And now we do our crisscross. So here, the 2 is going to be a subscript there. The 1 is going to be a subscript there. And so we're going to write zinc with just 1. We don't write the 1s. And then the 2 for the polyatomic ion. Since we have 2, we're going to have to put our polyatomic ion in parentheses and put the 2 on the outside. And so we can see that the 1 here and the 2 are lowest whole number ratio, so that's not reducible. So this is our formula for zinc hydroxide. Okay, the last one, aluminum phosphate. So again, aluminum is in group 3, so it's going to have an 3+ charge. And phosphate is again a polyatomic ion you need to know. That's going to be PO4 3-. And again, we're going to do the crisscross method. So the 3 for the aluminum becomes a 3 for the phosphate, and the 3 for the phosphate charge becomes a 3 subscript for the aluminum. And so we write aluminum 3, PO4 3. Notice the 3 is on the outside. So PO4 we don't do anything to. And so now we're looking at the subscripts, the subscript on the outside of the parentheses with the subscript for the monatomic aluminum. And we see that that can be reduced. 3 to 3 can go to 1 to 1. So we can get rid of the parentheses and get rid of the subscripts. And so we'll just write the subscripts 1 to 1. And again, we don't write the ones, so it's just going to be AlPO4. That's going to be the formula for aluminum phosphate.